I'm going to talk a bit more about how we are utilizing MISP into our incident response team and into our plans on working. So a bit of background. I work at JN Data in Denmark. I'm a cybersecurity crossfitter, incident responder, and working with threat intelligence. And also the founder of eCrime Labs in Denmark. I've been working with MISP since around 15, where I first started. And then I've also been a part of implemented it into my current workplace. So some places that we also use MISP is the statistical data that has come in, like the MITRE attacks. These things are really good for us because we can use it to identify in the incidents that we are analyzing what we're seeing on what should be prioritized in protecting, trying to avoid this happen again. Because a lot of times it's like, there is a lot of different things occurring during an incident, but what was some of the things that we are seeing again and again? Like in this case, it's spear phishing with attachment, it's with links, all these things. The next thing was that we actually also started to use this with vulnerability management, because any of you have issues regarding prioritizing patches, some use like CVSS scores and other things like that. But what we tried to do was also to start using CV numbers that were mentioned or located in MISP. So if we had seen a vulnerability being exploited or being mentioned in MISP, we actually use that in the prioritization phase to decide again how we can counteract some of these attack types. So these were some of the preparation parts where we are using MISP today. So the next thing is how you can use MISP to be an incident response superhero and actually use it as a SOAR platform. Our challenge today is that we have a bunch of services, we have a bunch of governance around it, working in the financial industry, and we have a lot of customers. So technologies across everything, different integrations, platforms, systems all around. So this was one of the issues that we were facing, is how can we do the best incident response across all these different areas at once. So the first thing that we needed to do was to ensure that we had coverage. So we needed to have either coverage for blocking or for detecting, meaning log management. We needed to have insight in network, endpoints, and logs. And at least two of these is needed to be able to always have the biggest chance to see an adversary that are coming into our systems. So with this in place, we now also have the course of action part. So with course of actions, you have the passive part where you don't want to alert the attacker on that you're actually monitoring them or seeing them or searching for them. And then you have the active part where you want to deny their access, like firewalls, disrupt, could be antivirus, degrade, could be various other things to get out of it. It could be like implementing quality of service. So if you had an adversary IP address, you could lower their bandwidth to 1 kilobit or something to give them a hard time working in the environment. So the way that we mapped this into MISP was that we wanted to use the tagging, and thanks again for the local tagging part, really useful here. So we wanted to have like different tags that we added to the system to then map against if it was a passive or an active defense mechanism that we wanted to work with. So we have like alert tags that are used only for passive triggering, meaning that we want to search or see in real time with these indicators. So these tags can be set both on the entire event or on individual attributes. Logging tag says itself that you want to block something. Now you want to go into the active part of it. We also have the hunting part for our CM solution. So when something has this tag onto it, the hunting tag, it will then search backwards in time to see if there's been any hits in the past on it, because that's also really important part of it. And then we have the incident tag for when we need to do both the passive and the active defense at once. And of course, false positive, because we don't want to, when we have incidents that we describe into the MISP, that we are then removing out of the MISP. We just want to mark them as we've seen this. We know that they're there, but we then pull them out. So looking at it into the capabilities during an incident, so you have the passive discovery and detect with the 3 alerts on ransomware cases. You want to act while you learn more about the incident. So in that case, as soon as you add the incident tag, this data will start to work its way out into our infrastructure. And then we have the block tag is more for, you can like use it to create a playbook. So you can do all the passive analysis first, say, okay, now you have a good idea on how far or where the adversary is in your network. So we have all the IP addresses, we have all the domains, we have the URLs that we know about. Now we want to block it, and then we actually push it out. So one of the things is for Elastic is that you can use memcache. So we have a Python script that pulls data from MISP, stores it into memcache because it's memory-based, it's fast, and then we let the Elasticsearch or Logstash actually look at it in real time when data comes in at the fly, on the fly. And then we also use the more, we're going to say the hunting tag. That's where we then use ElastAlert to go back and do the search. Carbon Black, you can also now push in or provide the MISP directly into Carbon Black, so you could use it again to detect binaries or domains or IP addresses from it. But again, this is from the passive side. Again, a lot of times that we've seen is that it's a matter of also not making the adversary aware that they actually been spotted before you start to counteract them. And this part was actually what originally started it, was that we had, I don't know how many of you have been on incidents where you're really good at analyzing and finding whatever happens. But when you come to the point where you want to start the containment and eradication and trying to implement 10 IP addresses in 15 firewalls across multiple customers, combined with URLs, MD5s, hashes, you name it, trying to get all that to work and be done within 30 minutes with people and change management system, that can sometimes be quite hard. And we also saw this, and sometimes it failed because you have people involved. So what we did to counteract this was that we became our own feed provider. So similar to that, you have firewall providers that pull down URL feeds or IP feeds from various sources. We just, as a security department, became a feed provider to our own organization. And that's a way to work in the system, meaning that that's not worked under change. Change doesn't apply to these updates and feeds. Of course, we have things in place to ensure that if something like a false positive comes in, we can swiftly get it out, because it's like a maximum of every 15 minutes things are getting pulled. And this means now that when we're pushing these data, it gets pushed into the anti-malware system, to the proxies, to DNS servers, to firewalls, to mail gateways all at once. And across multiple customers, across multiple platforms. So the full stack looks like this. Also, we saw that we're getting a lot of valuable information from external parties, and we wanted to gather these in a centralized location, and that's where we're actually using also the MISP, because it's a good way to store it and get it out and working in the organization. So we have a small API in front of the MISP that are then delivering to all these different systems, because some of the systems out there, like Carbon Black, needs a particular way to get data represented or presented to them. And then it actually feeds to the system. And when we see some of these data, it then comes back into the CM. If an alert is then seen, or if an IP address is seen, we get an alert up into the Hive, and then we can work again from there. So this is our way to have like the cycle all the time going through. The incident responders go back. So a good idea is there also to actually have a local MISP instance. So each incident responder has a local instance of MISP running on their laptop that they synchronize up with their centralized system. And this is to ensure that you always are able to bring this. This actually allows you also, if you're in some air-gapped location where you don't have internet access, you still have the data. So you can still use this in your actual incident response plan or when you are doing forensics. And afterwards, when you're done with the incident and you get back, then it gets synced up and can be used by everyone. So one of the troubles that we also had during this was, how do you test it? It's not like just taking some newspaper site and start blogging to see if the entire chain works. So I created a small website called EvilCorp.dk, where I have a lot of indicators around this website, like binaries that are not malicious in any way, but can be used to test this entire flow if you also want to work with it. So it's a site if you want to dig deeper into it. And last but not least, this was what I had to. Some of the code is located on my Git, and if you have any feedback, it'll be good here.